So for this homework this week, you're going to learn about Boolean logic gates. So this homework will be split into 3 sessions where you're going to learn what each gate is. Then you're going to decode each gate, and then you're going to complete some tests. Okay, so nothing to worry about now. So first of all this week, you're going to understand the functions of each logic gate, and then you're going to explain how each logic gate works over the course of the 3 weeks. So the gates that we're focusing on, these are the gates here. So the NOT gate, the OR gate, and the AND gate. Now, how these gates work. So this is how I remember each gate. So this is the NOT gate, as you can see on the screen. So I think of this as like pineapple. Okay, so I would call that a pineapple. And then on the end, I would say that that is the cherry. And a cocktail stick is going through it. So this is your NOT gate. Now, the NOT gate will do the opposite of exactly what is happening. So if you remember our Boolean, okay, so Boolean is simply true or false. Okay, with Boolean there's only 2 answers. Okay, true or false, or 1 for on and 0 for off. Okay, or yes or no. Okay, so that is your Boolean. True or false, yes or no, or on or off. Now, the NOT gate does exactly the opposite. So remember our NOT gate, so it's our triangle here with the cherry on the end, and you've got the cocktail stick running through it. So it's got the cocktail stick running through it, okay? And so if the input is on, okay, which would be, just redraw this, I just got another pen, which would be number 1, what would the output be? Okay, hopefully you've said the opposite, which would be 0. Okay, so that's your NOT gate. So the NOT gate does the exact opposite of what you want it to do, okay, or what you would expect. Now, next thing is you've got your OR gate, okay? So as you can see the OR gate on the screen here, I always think of the OR gate as a spaceship, okay? So we're looking at that, there's how it flies right there, okay, so that's your spaceship there, and there's the laser coming out of it, laser beam. Now the OR gate doesn't mind, okay, what you do. So if the input is 0, okay, what would the output be? Hopefully you said 0. Now if we was to change one of those to 1, okay, so you've got your input as 0 and then the other one as 1. So remember, this is OR. What would the output be? Hopefully you said 1 because it's an OR gate. Okay, so it doesn't mind what it does. So as long as either one of those circuits are turned on, the output would be on. Okay, now for our final gate, that's the AND gate. Okay, now I always remember the AND gate is a great big D. Okay, like because you've got D on the end of AND, and it's got 2 inputs here. Okay, these are the 2 inputs there, and then it's got one output. Now AND can only work together. Okay, so AND cannot go without its friends. So we've got 2 friends here. So this number 1 would be Mick, the other number 1 would be Bob, and Mick can't go anywhere without Bob, and Bob can't go anywhere without Mick. Okay, it's a bit like I don't know, Ted and Barney in How I Met Your Mother, or Sheldon and Leonard in Big Bang Theory. Okay, so if there's a 1 here and there's a 0, okay, so Sheldon wants to go to the comic book store. Okay, so number 1 here is Sheldon, and Leonard doesn't want to go, what do you think would happen? Okay, hopefully you've said Sheldon's not going to the comic book store, so the output would be 0. Nothing would happen. Okay, because and is dependent. Okay, one is dependent on the other. So if both of these are number 1, so if Leonard decided to give in and go to the comic book store with Sheldon, what is the output? Okay, hopefully you said the output, they're going to the comic book store, number 1. So both of these circuits have to be on or off, okay, for it to work. Okay, so that is the NOT or AND logic gate. So for your homework this week, I would like you to please complete a poster about the NOT or an AND logic gate, and I'd like you to briefly describe how they're used and where they're used. Okay, you can do a bit of research on that.